Hi, this is Prof. Redder, and this is part two of a series of two videos that talk about the motivation for creating classes, objects, using object-oriented programming. A lot of this won't make much sense if you haven't watched most or all of the previous video with the same title, part one. So what we're looking at here is exactly the code that I left off with in the previous video. And the problem that we see here that I mentioned is that this doesn't have any concept, any definition of what we mean by a checkbook account. It does talk about setting the balance and getting the balance, setting the transaction amount, and getting the transaction amount, and what to do when the user wants to do a deposit and a withdrawal. But we really need to be able to discuss this in the context of having an account object. And that's what this is about. So what I'm going to do is I'm going to create a thing called a class, and the class is going to be called account. And an account is going to be made up of some fields or properties, if you will, and those properties together, the cross product of their data types, will be the housing for the actual account objects. Then we're going to look at how we can go about creating an account object, and then we're going to write code for all of these things to help you see how we can improve the problem that we have on the solution that we have. Now, I already mentioned 3 times, I think, that we don't have an account object, but we also have some other issues, and one of them is that the UI that you see there in the name of this file, checkbook UI, stands for user interface. And in fact, it is meaningful to have a method that takes care of action performed on the withdraw button or on the deposit button, and on the transaction amount button or field, although this is just a mistake to be here. But really, the business of being able to carry out an action is a user interface. But how to go about carrying it out is not a user interface issue. So we need to be able to connect what we're looking at here with what we're going to define as an account. And so with that in mind, I'm going to start making some changes here, and I'll explain what I'm doing on the way. So up here under source packages, I'm going to right click, click new, click folder, and I'm going to name this thing account. And I think I'm going to put a capital letter there. And it's in the checkbook project, and that's just fine. The parent folder is going to be source, and if you go look at the file structure, not here but so much, but in your folder with this, you'll see that there is a folder called source, as we saw early on. I'm going to click on finish. And now I've got this account class that's sitting here, or account folder right here. I'm going to right click on that and click on new, and now I'm going to click on Java class. And I'm going to call this Java class account. And you need to do this. This name needs to be the same as that name, which is, I'm not real pleased with that, but it is. Notice also that it talks about it being a package called account. That's going to be an issue for us, but it's easily resolved, but it's going to be a little bit different. So I'm going to click on finish, and now we have this structure that you see. We have a folder called account with a file in it called account.java, and this file is in fact the container for a class that is called account. Again, this class name needs to be the same as the name of the file. Okay, so I mean the name, not the extension. And so beware of that. What we want to do is to create an account object over here somewhere, perhaps in the user interface, that will allow us to manipulate the account through methods that the account provides rather than through methods that are provided in the user interface. Because setting the balance on an account is really not the job of the user interface. It's the job of the account itself. we also notice that we have this withdraw action. Doing a withdraw, knowing the algorithm that we use to do a withdrawal is not the job of the user interface. The user interface's job is to put it in front of the user to say, click here and we'll take care of it. The we'll take care of it part needs to be off in the account itself. So we're going to create this class called account. And in this class, we're going to have all of this functionality that allows us to manipulate the account object. Okay, so you need to start thinking differently. Instead of having a transaction amount and a balance, we need, and instead of having withdraw and deposit actions that occur in the user interface, what we have is none of this. We're going to probably even create some additional methods, and this is not going to be something that knows how to go about setting the balance. It simply knows that this button got clicked, and that when that button gets clicked, we want to have the balance set in some other way. That's our whole goal. So what I'm going to do now is to populate this account class with code that describes what an account is and the kinds of things that it can do for you on its behalf, on your behalf, do to itself actually. So I know that I want to have a balance, and so this is going to be a float balance. And some people use different kinds of naming conventions. You can feel free to come up with your own naming convention. I'm going to have two operations. One of them is going to be to public void deposit float an amount. There's going to be a method that does that. I'm going to have public void withdraw, and we'll talk about why it's void or not later. And so now we have these two methods that we want to be able to execute as a result of calling them, and we're going to call them with this amount. This looks very much like what we did over here in this code by getting a balance and an amount, except now we're going to just change the balance in the account itself, and then we're going to set the balance in the account to some different value. So if we take a look at that, let's take a look at withdraw, and what can we do? If we look over here, we can say this. I'm in deposit, and I can simply say balance equals balance minus amount. I can come up here and I can say balance, and this balance that I'm using here is this one right here. Okay, this one and this one are the same. This one and this one are all referring to the same balance. And we can also use for deposit, we could just say plus equals amount, because we want to take the current balance and add to it. So we can do it either this way or that way. And of course this is the preferred way, so we'll do that. But either way is really fine. You can't deny that. You might want to change that more than just author Dave there. And so we have the ability to do this deposit, and we have the job of getting these values from somewhere. Now you can argue this in a bunch of different ways, but actually this value of the balance is part of the user interface, all right? But I don't need it anymore. I really don't need it, because the account that I'm going to create is going to maintain that balance. So I'm going to delete that. And this thing now is part of what's going on. In other words, this get transaction amount does take into account that in the user interface, I've got this thing called text field, and I want to get the text from it. I also know that I want it to be a floating point value to pass forward. And so this one's kind of on the fence about whether it's user interface or account stuff, but I'm going to leave it in the user interface. And then this thing right here also has the same behavior. I'm sorry. Yeah, okay. This thing here has the same behavior, so I don't need the balance. I'm going to have it in the account. I'm going to get rid of that. And I don't need to set the balance here because that's going to happen in the call. Oops, my bad. In the call to the accounts deposit or withdrawal methods. Okay? And we're going to come back here and I'll show you some reasons why this is more valuable than having it in the old way. And I've got it all torn up into pieces now, so there's no, well, there is going back, but we don't really want to. Notice that these two now are never used. That's what the gray underscored squiggly thing means. I'm going to get rid of them. I don't need those. They didn't really have anything to do with the user interface. They had only to do with the account that we sort of had embedded in the UI. So this is user interface stuff because I'm dealing with one of these fields. This is for the same reason. This thing is user interface stuff because I'm in the user interface getting the transaction amount, but I then want to send that transaction amount to the account object, but I don't have an account object. And so what I'm going to do is up here in the class itself, so right in here, actually no, in the UI itself, right up in here, I'm going to create an account object. And that's the way you do it. But notice here that it's got these squiggly reds on here. It says it can't find the class account. And the reason is that the class account is defined down here in account and not up here or down here in checkbook. So if you hover over this, you'll see at the very bottom there it says Alt-Enter shows hints. This can be pretty useful. Double click on that to mark it, then press Alt and hit Enter. And it says, well, do you want me to add an import for that or create a class account in the package checkbook or what? Well, it turns out that this thing, account.account, is referring to account.account. That's the one you want. So if we click on that, it creates an import, and there it is. It simply says import account.account. So that says that this is now visible to us, and we can, in fact, refer to it. We can use this thing, which is called the constructor, which I'll show you in a minute, and account. So here we've got this thing called new account, and it's creating an account object. Now we've got an account object that has a balance in it and knows how to do deposits and withdrawals. And we've got this account variable, which is really a pointer to an object of this account class. So what do we want to do? Well, we can just leave it at that, but it's a little bit more convenient if we have an actual constructor. So what I'm going to do is this. And what I'm going to say is balance equals 0. So when I create, let me hold on a minute. I got something. Well, I forgot about something here. I can't just say balance equals 0 because that's an int. And if I put .0, that's a double, and it doesn't like that either. But if I put an F after that, then it likes that. So what I've done now is said when you start this, when you create one of these objects, what you need to do is to set its balance to 0.0 float. And that will be the initialization for that object that you've got. So every time you create one, calling this constructor, it will do just what I just described. So now when we come back over here, I really would like, instead of having this guy have a 0 in there? I think I'd rather just have nothing in there. Just to show you what happens here. And I'm going to leave that one at 0 like that. But now when I come back from the constructor, right here, this account object is going to have a value of 0 in its balance field. If I could mark that. It won't let me do that very easily. Okay, so this account is going to have a 0 in its field called balance. What I'm going to do is come right here and I'm going to set that m_tf balance dot set text to, actually I want to say account, let me get that out of the way, account dot balance dot to string. And it needs to be a string because this is set text and it expects a string. Now we've got another problem, and the problem is that balance, it says balance is not public in account, so you can't see it from here. Now, I don't know if you have all dealt with public and private and protected, but I'll mention it to you here right now. When you have something as you have right here, balance is declared. If you don't say otherwise, then it's considered to be private. This isn't necessarily the case in every language that you'll deal with, but in Java it is. Different languages may use different rules for this. Our rule now is if we don't say otherwise, then this thing is called private, and its value is only allowed to be dealt with when you're within the account.java class, when you're in the account class. So we would like for this thing to be available to us, but it kind of violates the spirit of this. But if I were to do this right away, let's just do this to start with. I'm going to put public there, and I'm going to come back here and hit save everything, and even before then it got better. And you can see now that account.balance is no longer a problem. When I take public out of there and come back over here, it's going to become a problem again. All right, so one thing that you can do is the easy thing, and that is to do this business, just make it public. I don't want to do that. Instead, what we're going to do is create something called an accessor function. We're going to make a public function called float get balance, and its only job is to provide that balance to the caller. So I'm simply going to return balance. Now notice that this is private, and as a result only things in here can refer to it. Well, this is in here, and so get balance can refer to this, and when it does, it's going to refer to it by grabbing this value and returning it. So over here I'm going to say account dot get balance. That's a method, returns a string to string. Okay, now that may seem to be a lot of extra code for no apparent value. However, this turns out to be at the center of, or in an important spot in the concept of object orientation. And so I want you to make sure that you do these kinds of things. One of the reasons, just to give you some motivation for doing this, is that you may want to intervene on getting balance. You may throw into here get balance with an argument, or you may want to do something which would maybe be some credentials that say I'm allowed to get the balance, or you may want instead to have something that does logging. Balances were requested this many times, and if you want that, you can put it right in here, right before that return statement, to log that somebody got a balance again. And that may just simply be some kind of business logic that you want, some kind of business information that you want to return. But getting in the habit of having these kinds of things available to you can be really quite useful. So I'm going to ask you to do that. And when I see that you didn't, I'm going to make note of it for you. I'm going to remind you that you need to do these kinds of things. Lots of the front end of learning how to do object-oriented programming seems really pretty goofy. But as you develop these techniques and understandings, I think you'll see the value behind doing all of this. All right, so let's just run this thing. And if you'll recall, we don't have anything in there anymore. And it's all saved, so nothing's changed. And so when I do this, all right, it's going to do the initialization of all the components. And those are the things that putting the various controls on the page and positioning them just so. This thing ought to set the text of the balance, the m_tf balance control, to the balance that we set as the initial balance in the constructor. So let's run this thing and see what happens. There it is. Balance is 0.00. Before it was just 0. It was just 0 because I just literally just put a 0 in there. But now it goes to get the balance, and the balance is in fact a floating point value over here, and it returns float. All right, get balance returns float, and float is represented with a 0.00, which is why toString converted this thing to 0.0, and that's why it appears in here as 0.0. So you can see, if you take the time to look at these things, you can see that this is actually going to, or what's actually happening. Okay, another way to see it would be to come over here and account balance, and instead of setting the balance to that, set it to 100 and see if 100 shows up in there. There it is right there. So you can see that this is doing exactly as we've planned for it to do. So I'm going to set that back to 0 so we don't get confused later. Save all that stuff, and we've got a running application. Well, let's see what happens when we just use this stuff on deposit and withdrawal. So let's come over here. Here's the deposit button right here. There's the amount that we want to deposit. We should be able to call, since account is defined at the class level. I mean, it's not a member of this constructor or anything, so it should be a visible value any place within the class. We should be able to say account dot deposit. I want withdrawal, don't I? Withdraw. Oh, and it's not called account. That's the class name. This is the variable, the class variable with the lowercase. And there's withdraw. Amount is, because we said it was. That ought to take care of that. And this one should look pretty much the same, except we're going to say deposit. AMT. And we're almost there, but there's still something that's not going to be what we want. So let's click on this. We've got 0. We'll say we'll do a transaction amount of $34.56. Click on deposit, and we still have no money in there. Well, why is that? Well, because we did the deposit, but we didn't record it. So every time we do one of these guys, we really ought to update the balance as it appears. So let's go back over here and notice that we did update it in the account, because we simply said add this amount to the balance, subtract this amount from the balance. But we didn't do anything in the UI to reflect that. So let's throw in a method here, our own method. We'll make it private void, and we'll call it update balance. And in fact, I think I'll put this upstairs a little bit farther. I think I want to move it up here with the stuff that I wrote, okay? Rather than the stuff that was kind of UI only stuff. So I'm going to say update balance, and I'm going to say, what was it? It was m underscore text field balance dot set text, And what I want to set the text to is account dot get balance dot to string. What do you think? So now every time I update the balance, put parens there, it's going to do that. But I don't call update balance anywhere. So I need to put it down here and tell it to. Both every time I do a withdrawal and every time I do a deposit. So now if I run this thing, whoops, what's going on here? Oh, I didn't get rid of that piece that I dragged. I control dragged it instead of just dragging it. So let's run this thing. Notice that it saves, by the way. I'm going to set a transaction amount to $34.56. Click on deposit. Now I got a new balance. If I click on $15.18, click on withdraw, I've got that. Notice here that I got a little bit of a goofy thing going on, and that's because I just simply said float and I didn't tell it how to format the floating. Floating point values are not specifically accurate. I mean, they're accurate, but not to infinite degree. And this one's got a little trailing one out here, and we're going to deal with that later. But for right now, I don't care, and we'll worry about that detail at a later time. We'll put 15.93, and we'll take it out of there, withdraw, and we continue on. All right. So right now we've got an actual working app that uses classes, and those are the things that I want you to start thinking about. Notice that we have an account object here. In the previous version, we did not have an account object, but rather had things that were sort of dealing with the account, but they were all being done within the user interface. We've got a UI object called account just to give us access to back and forth between this and what is actually called the data access layer. This is the user interface layer, and this is the data access layer. And this is an account object. This is a class. I shouldn't have said an account object. This is a class that has a single property, and so this is a member of int. The class objects are members of the class float. We have some operations that we can perform on it, and this one right here is really not that much of an operation other than that it goes and gets the balance. We could also have a set balance here if we wanted, but we don't need it because we're going to set the initial balance with an initial deposit. So there's lots of things to be said about all of this right here, and we'll talk about more of that as we go. Your job right now, whether you're just watching this video or if you're in my class, either way, your job is to come up with something that's meaningful. Something that's along these same lines. Perhaps you would like to write the app the way I wrote the first checkbook app and then go modify it. Perhaps you would like to start with an app like that and write it the first time out the gate as an object-oriented application. If you're having trouble trying to think of something to do, maybe you could check or try to write a tip calculator for a restaurant bill, where someone gives you the bill, it's got the grand total, and you would maybe gives you a couple of buttons to push if you want to do 20% or 15 or 10% tip, then calculates the tip and the grant and the total with that. Perhaps you'd like to be able to track stocks or a single stock as the daily value goes up or down based on the number of shares of that stock that you have. Maybe you'd like to do something like a Fitbit or a calorie counter with an exerciser of some kind. Maybe you'd like to do something where you could collect square footage in a house by looking at various rooms and decide how many square feet on these different rooms. So you'd enter a length and width, a length and width, a length and width, and each time you did that, it would add that to the square footage that you've collected. Any of those are really quite simple concepts, but that's where you need to start in order to create those things. For example, the restaurant bill tip calculator. your class might be restaurant bill, and the restaurant bill has several parts. It has the initial total, it has the tip percentage, it has then the tip amount, and the grand total. So you would take the tip, the starting total, take out the tip amount, which is calculated based on some button someone pushed or whatever, and so forth. So just keep in mind that what you need to do is write this so that you are separating the things from the user interface from the things in the actual object that you're manipulating through the user interface. I think it'll be a fun assignment to do. Please don't get discouraged. Refer back to this code that you've seen here on this video as much as you'd like. I will push this up to the, I will try to push this up to Programming 2 tonight. I'll get it up there pretty soon. And hopefully that you'll have a good time. That's a long video. It's almost 30, well, it's over 31 minutes by the time I quit rambling on. I hope that you have a fun time. Please, again, don't hesitate to contact me. You'll be expected then to write a paper that describes your experience, as always. Good luck, and let me know if you need help. Bye.